Okay, one more from section 11.1. Does this sequence converge or diverge? Well, if you watched the last podcast, number 66, I sort of gave a hint, because if you have a sine function, so a trig function will, or sine or cosine, will go up and down like this between +1 and -1. And when you divide by the 1 plus n, that means you're dividing by bigger and bigger numbers, so the sine wave should calm down and eventually level off. Then let's take a look at the graph and see if that's actually happening. So I need to graph. Oh good, y equals, and then sine of 2x divided by, parentheses, 1 plus x. And then for the window, have it go from like 0 to 10. And then the sine graph, the biggest it gets is 1. So if I have it range from -1 to +1, I should be able to see the graph. And then take a look at it. And yes, so this is called a dampening wave function. Sort of like the sound of my voice right now is waves. And notice as I stop talking, the waves disappear. So that's basically what's happening with this one. So if you follow it farther and farther out, you'll see that it gets, okay. If you follow it farther and farther out, okay, that looks even cooler that way. So it was, as you follow it, oh, that's a weird, I wonder if I should redo this video. So if you follow it farther and farther out to the right, then you could see that it gets dampened and it's becoming 0. All right, then can we actually prove that? So it seems that the answer is converge. Let me get a pen. It seems that the answer is converge. And not only that, I think that by looking at the graph, it's going to converge to 0. So what is the limit as n goes to infinity for sine of 2n over 1 plus n? And with this one, we cannot use L'Hopital's rule, because L'Hopital's rule only works if you have a blue pen. And you get infinity over infinity, or you happen to have 0 over 0 when talking about limits. Then you could use L'Hopital's rule. But sine ranges between +1 and -1, so it's not becoming a 0, and it's not becoming an infinity. So that means that we can't use L'Hopital's rule. But what we can do is say, well, sine at the very biggest it gets is 1. So that means that the top part is always less than or equal to 1. So that means that the whole thing is going to be less than or equal to, let me just erase this blue guy for a second. So that means that when you take the limit as n goes to infinity, then the top part's going to be less than or equal to 1. So basically I'm just saying sine is less than or equal to 1, and then I'm recopying everything else, which is perfectly legal. Okay, and the bottom is still the 1 plus n. And then if n is going to infinity, that means this becomes 1 divided by infinity, and that 1 divided by a huge number is so small, it's 0. And so what the graph was telling me is correct. This is becoming a 0. That means converges. And therefore, converges to 0.